Okie dokie. So we were able to share our grades or I was able to share grades with you today regarding Unit 2. We are moving into Unit 3. I just want to put this here because I did not include it in the slide there. We are in Unit 3. This is going to be Lesson 1, okay? And we're going to be Lesson 1. Okay, classifying triangles. Today you're going to be able to identify and classify triangles by their angle measures and their side measures. Okay, so this is our introduction to classifying triangles. Let's move on. Okay, take about 10 seconds, and excuse me, I'll come back. I'll put pause here in 10 seconds, but go ahead and do this do now. Push pause now on the video. Do the do now on your Pear Deck, and check back. Okay, so after you've done it, let's look at the math test quick tips. Once you've read through those, you do notice this is an ACT question. You can kind of tell because it's number 20 on the ACT. I believe this was from last year. Okay, and we're asked for trapezoid ABCD shown below. Line segment AB and segment DC are parallel. The measures of the interior angles are distinct. This word distinct means that they're all different, right? It's an irregular trapezoid. And the measure of angle D is x. They tell us that right there. So what is the degree measure of A in terms of x? So hopefully, I think some of us were able to kind of see that if I did this and I kept doing this, right, I would realize that this angle and this angle are same side interiors. Well, same side interiors are supplementary, right? That means they equal 180. So if I had x, for example, and I subtracted it from 180, I would get the measure of angle A. Okay? And A would be the answer. Okay, let's go ahead and move on to our lesson. Okay, so today we'll be able to classify triangles given angle and side measurements. Classifying triangles. Let's go to the triangle basics. So a triangle is a three-sided polygon. It is made up of sides, angles, and vertices. Vertices is just a plural form of the word vertex. Okay, so here are your sides. It has angles, okay, the angles here. And it has vertices, which actually are kind of the same thing as angles in some way, right? Vertices are right here as well. It's basically where two segments meet. So it's actually the little point, right? So these are your vertices here. Okay? A triangle can be classified by sides and angles. Let's move on. So classifying triangles by sides. When a triangle is classified by its sides, it can be scalene, isosceles, or equilateral. So let's kind of go into this a little bit more in depth. A triangle with no sides congruent to each other is known as scalene. Okay, these are probably 7th, 6th grade review terms, but we're going to get much deeper into the math and geometry on triangles here. Let's go to the next one. A triangle with at least two sides congruent to each other is known as isosceles. Okay, isosceles, which means that there are two congruent sides. And lastly, of course, a triangle with three equal sides or all sides are congruent to one another here is an equilateral. Okay, equilateral. Okay, let's move on. So we just did that by sides. Now we can also classify triangles by angles. So when a triangle is classified by its angles, it can be acute, obtuse, right, or equiangular. Okay, so a triangle with three angles that are less than 90 degrees is known as acute. A triangle with one angle that is greater than 90 is known as obtuse. And a triangle with one angle that is exactly 90 degrees, most of us know that as a right. Okay, and then this last one here, which we don't use too often in terms of term, is called equiangular. It is the same, if you notice, as an equilateral, right? If all the sides, all the angles are equal, then naturally all the sides will be equal. We'll dive more into that statement in a little bit. So these are going to be equiangular. Equiangular. Okay, and here's that word right there. So let's get into a little bit of guided practice here. Let's do a little my turn. So we're going to classify the triangle below by sides and by angles. Okay, so by sides, I have a 7, 12, and 10. None of these are equal. This is what we know as a scalene triangle. Okay, and by angles, well, it's the same thing, right? If none of the angles are equal, and in this case, less than, not really so much equal, but because all the angles are less than 90 degrees, this is known as an acute. Okay, let's go ahead and take a few seconds and try yours. And once you went through yours, classifying the angle below by sides and by angles, you should have gotten the following. And that would be a right isosceles triangle. Okay, let's go. So let's go ahead and do our turn. Notice that I included here the distance formula for you. We're going to be using that. Directions. Find the measures of the sides of triangle JKL, then classify it by its sides. Okay, so let's go ahead and take J first. Here, J is negative 7, 7. I know it's not the prettiest looking one here, but I'm going to mark these. And on this one particular one here, I'm going to go a little bit quicker, get the distance formula for KL. So once I substitute my values for KL into the distance formula, I realize as well it is the square root of 68. Okay, so this is also, at least we have an isosceles. We may even have an equilateral. So I'm going to go ahead and do that last one, JL right here. I'm going to do this in green. Okay, so once I substitute my values there, I'm almost finished working it here. The distance for this, of course, would be then 36 plus 36 is 72. So here, the square root of 72 is the distance from J to L. It looks like we are dealing with an isosceles triangle. All right, we're asked to identify it and classify it by its sides. So in order to find what the side distances were, I put it into the distance formula, figured out each side, and identified this as an isosceles triangle. All right, let's move on. So let's do some independent practice now. Okay, so I'm going to go through, I'm going to show you how it's going to look. I will do this one. You will do this one. I will do number 3 for you to show you how it's done. Okay, so I'll do 3. Yeah, you'll do 4, 5, 6. You'll do you'll do all the ones that I don't do, of course. You're gonna complete all the problems. I will. This is the one like we just did right now. Number 7, 8, 9. You're also responsible for, as well as 10. I will do one of these here. I'll probably do 13 or 15. So I'll do one of these myself to show you how or what the expectation is. I will start to model this one here. Maybe I'll do part A for you. And lastly, you'll be doing the exit ticket on your own. Okay? Again, this is going to be a double grade, so it's very important that you complete all of it. If you have any questions, please feel free to reach out to me, and I will help you the best I can. Take care. Have a great one. Thank you all so much, and good luck on the ones that you're going to finish there on your own, of course. So let's go ahead and number 1 here. Classify each triangle by its angles and sides. So I'm looking here. I see 2.8 and 2.8. So basically, I'm going to use my geometry terms. That means this and this little tick mark are telling me that those two angles are congruent. Okay? Excuse me, those two sides are congruent. These angles here, right? I'll do like little things here. I can just use 2 tick marks, let's say, for example, and that will be also identifying that this is an isosceles triangle, okay, by its sides. And of course, by this angle here, okay, that right there is a dead giveaway that this is a right triangle as well. Okay, so this is a right triangle. So it's a right isosceles triangle. Okay, by the angle and sides, right isosceles triangle. Alrighty, so let's go ahead and you will do this one now. Okay. You can refer to this page and this page in your notes. Okay, and hopefully you have identified this as a obtuse scalene. Okay, I have 3, I have 5, and 7.1. You notice none of those tick marks are the same, right? I have 35, I have 20, and I have 125. Okay, so I am working with a obtuse, the angle, and I'm really talking about this angle right there being greater than 90 degrees, and this is an obtuse scalene because there are no sides that are equal. All different distinct sides. Moving on. Okie dokie, we're going to classify each triangle by its angles and sides. Equal sides and equal angles, if any, are indicated in each diagram. So let's go ahead and take a look at this one here. Okay, I'm going to say by angle, I know right off the bat that is a 90 degree. Okay, so that is a right. And my sides, I have 1, 2 sides are equal as well. Their corresponding angles are equal here, right? So here and, of course, here, right? Those angles are equal. I'm looking at a right isosceles. Okay, let's go ahead and give you a chance to work through these as well. Go ahead and pause now. Okay, and so let's go ahead and through these here. Again, I have this looks like an obtuse isosceles. Okay, I have two equals congruent sides, and this angle is obtuse. Okay, This here would be an equilateral equiangular triangle. This one here, there is nothing that indicates any congruence or any equality. So this one here would be a scalene. Should be an acute scalene. We have not been given any indication that there's a right angle in here, and you do not need to be told that it is an obtuse. There's always at least, every triangle has at least two acutes. The third one can be acute as well. So this would be an acute scalene. Okay, let's look what we have coming up next. So we've done a problem like this. You can go and take a look at that one with the distance formula, of course. You'll do 7, 8, 9, and 10 are, those four problems, 7, 8, 9, and 10, are very identical to ones we just did earlier with the distance formula. Here, you're asked to sketch an example of the type of triangle described. Mark the triangle to indicate what information is known. So in an equilateral, I have something like this. Okay, I have 3 congruent sides and 3 congruent angles. Okay, you go ahead and sketch the next one. Let's try number 14. Okay, take about 10 seconds, or pause right now actually, and then come back to this. And a right isosceles, so I'm going to go ahead and sketch this. Now, I'm going to be very clear that I have a right angle right here. Okay, I'm going to sketch this here. Maybe erase just a little bit, take a little bit off there, make it look nice and neat. Okay, I know I have isosceles. It's going to tell me that I have 2 angles and 2 sides equal to each other. Now notice this. Here, you notice that this angle corresponds to this tick mark. Same as this angle, right? This one is indicating that that angle is opposite. So if I have 2 equal sides, naturally, or congruent sides, I must have those corresponding angles be equal as well. So that would be a nice sketch of a right isosceles. Let's take number 15, an acute isosceles. So we have, again, I have an acute isosceles. It looks like I have, isosceles tells me that I have 2 sides equal, right? Which means then the angle, let me redraw this a bit. Okay, so I'm told I have isosceles that say make those, which means these here must also be equal because that one is the opposite of that. And that is the opposite of that side. That angle is the opposite of that side. So this is what we're working with, an acute isosceles. You notice all the angles are acute as well. Number 16, obtuse scalene. I have an obtuse angle, so I'm going to make it kind of wide here. And then maybe I'll do something like this, kind of make it look kind of off because there's nothing congruent in this triangle. These are all so we notice here in this obtuse scalene there is nothing that congruence. All sides are different. Okay, as well as all the angles are different. So, and this is going to be our obtuse. Our obtuse part is right there. That angle there is obtuse. All righty, let's move on. Okay, you will finish this problem, but I will start it with you. If QN bisects PQR, and N is the midpoint of PR, classify each triangle by its angles and sides. So let's take this first part. If QN, right here, if QN bisects, means cuts in half, PQR, okay, PQR, this is PQR, and N is the midpoint of PR, we'll classify each triangle by its sides. So let's take the first part. A is saying triangle PQR. So PQR. Sometimes it helps to pull that whole triangle and redraw it over here. So I'm going to do PQR. It's PQ, and I'm just redrawing what they have there. Okay, I am told that this is 60 degrees. This is 60 degrees. This angle, this line I just drew right there, this bisector here, bisects this angle here, which means cuts it in half. We're told, and I'll just draw it on the outside, 30 degrees is this angle here. Well, if this here is cut in half, right, if this angle is cut in half, that means that this part in blue right here is equal to this part right here, which means then this here is 30 as well. Which means the whole angle then, the whole thing, is equal to 30 plus 30, or 60 degrees. They also give us these little tick marks here. There's not one here, but I'm going to go ahead and indicate it right now because I just realized that this here is an equilateral, equiangular, equilateral triangle. Okay? Last thing you're going to do, you're going to go through B, C, and D on your own. You will also do this final part of the exit ticket. Okay, it will be graded. Directions are to find the sides of D, E, F, and classify it by its sides. Okay, you'll fill in this information here, this here. You're probably going to have to use a distance formula. In fact, you should. If you have any questions, let me know. Thank you all.